All right, welcome everybody in attendance here today and joining us via live stream on Zoom. My name is Dennis Cohn. I'm one of the organizers of the Social Science Data Lab, and it is my pleasure to introduce Konstantin Gavras today, who's giving an input talk on Shiny apps development and deployment. Let me briefly introduce Konstantin, whom you can see here on the presentation and everybody at home can see on their screens right now. Konstantin is a PhD candidate here at the University of Mannheim. He received his BA as well as his MA from the University of Mannheim and has been studying here as a PhD candidate since 2016. He's currently a research associate in the MZES project, Fighting Together, Moving Apart, European Common Defense and Shared Security in an Age of Brexit and Trump. And his research interests specialize on social psychology and political behavior, in particular political attitudes and voting behavior. And his methodological expertise includes natural language processing, multi-level modeling, quantitative text analysis, and latent modeling strategies, as well as the topic of today's talk, Shiny apps. Before we start, here are just some logistics. You can find the workshop materials, which I will upload in a second, on github.com/socialsciencedatalab/shiny-development-deployment. And join our live stream under the link that you see here, which you can also find on our Twitter. So with that being said, Konstantin, we're very glad to have you here today, and the floor is yours.
Great. Thank you very much, Dennis. Thanks for the nice introduction, and thank you for so much for being here. Let me just switch to my presentation. Let's see. So today is going to be about Shiny apps, development and deployment, most importantly. So not only building our own apps, but also how to maintain, how to let them go live in the World Wide Web so the whole world can see them. But from the beginning, what is Shiny actually about? I think most of you have heard about this because it's kind of rumor, and it's become really popular in the data science community right now. It is basically a package developed and maintained by the RStudio team itself, so Hadley Wickham and all of the guys, including him, and it is used to build interactive homepages. So you can just use R to build your own homepage, and then let the users fiddle around with the interface to change results, change appearance of plots, visualize different things. And the great thing about this is you do not need to have any knowledge of web development. If you want to have a plain and easy Shiny app, you don't need to do any of HTML, CSS, JavaScript, or whatsoever coding. It is not the most beautiful app then, of course, but you have a steady and functioning app in the end. It fully interacts with R, so you do not need any additional software to run Shiny. It's just some packages loaded in R, and then R itself, and then you're good to go. And as I mentioned beforehand, allows for calculations. You can build your own calculator with the Shiny app, display different R objects, presentation of results, using as an appendix or something else. I've just provided you two examples to show what Shiny is able to do. These are two of my own projects. One is an interactive appendix of a paper just under R&R, and the other one is a private project I did for a data science crew with Correlate, where I'm socially engaged in. So let's check out these two apps, and hopefully they work. So this app is basically just an appendix for the paper Our Democracy is Dying One Generation at a Time, together with Alex Wuttke and Schön, currently under R&R. And the problem of our paper is that we have a lot of plots for the appendix and tables. So we decided not to provide 300 pages of appendix, but just putting them in an online appendix so that reviewers and readers can just toggle around, set different model specifications, set different samples, check for the temporal effects, because we were checking for cohort, age, and period effects over there, and check whether democracies are actually dying one cohort after another or not, and also taking into account several dependent variables. So instead of really providing a book of an appendix, you have an easy-to-use app where you can just check for anything and move around getting tables and plots. How do I get back to. So on the other one, it's basically another example, also not too difficult. You see the overall appearance is quite similar, but here we present just some descriptive results for the Me Too movement, so the social movement against discrimination and for multiple identities in Germany. Came along with the incident with Mesut Özil back then in 2018, and can just check the data here, see how many tweets and retweets per hour were on the Me Too hashtag, also checking for content, text, and all of this. So it's just like, it's another tool to present our data and especially to make it accessible for an audience not really into data science, not really into analyzing plots and tables professionally, but make them as easy as possible to use and to understand our results, and sometimes even run their own analyses on the Shiny apps. But enough of my stuff. Shiny app consists basically of two components, and this is what makes life for us quite easy, because it is basically just simple web development. We have front end, we have a back end. Front end is what the user sees. Back end is what we do, what we implement as a logic to provide the user a specific type of appearance, of plots, of tables, of whatsoever. So front end is just to get this concepts clear. It's just the HTML page written by Shiny. So Shiny writes a HTML page for us, and then we get the presentation when launching the app. It includes the layout, appearance, design features, all of this, what you can do, what the user sees in the end. In Shiny terminology, we call this UI, user interface. The back end is basically what lies behind. If you open up a homepage and check for the source code, this is more or less the back end, of course, with addition to some functions, logics, which are implemented there. This is basically the code, the R code running the app, including all functions, data import, whatsoever. Also involves the logic of the app, so checking which plots are shown when, which filter do we use, which if conditions are applied, depending on the input provided by the users. And of course, responsible for creating the objects on the front end in the end. So it's always the connection between front end and back end. In the front end, the user provides an input, the back end processes it and provides it back to the front end that the user sees the result. Just a simple idea of web development here. In Shiny terminology, this is called server. So we have the UI, we have the server, and we have our two components of the Shiny app. R allows us to set up Shiny apps in two different ways. So there's the possibility to have a single file app and a two files app. The single file app just stores the UI function and the server functions in one script. Just call it app.r and then you can run it. This should only be used for really simple Shiny apps, because it can become really difficult to have it all in one script. One normally does not want to have the full scale analysis just in one script, because then you have, if you're really unlucky, a few thousand lines of code and you have a complete mess. So the better solution, and the solution I will show you today, is the two files app. So we have a UI R script and a server R script, and just provides us a clear separation between front end and back end, and allows us to change stuff on the appearance of the app, but also change stuff in the logic, and to have really a clear idea what we're doing actually, and not having to search around where in the UI and the server are we now. The name of the files have to be UI.r and server.r, the same as above here. App.r are the requirements that these apps work in R. We're going to do this by ourselves in a second. The files always have to go in a separate folder, just because R just checks the whole folder, looks for the UI, looks for the server scripts. But if there are additional scripts somehow messing around with the Shiny app scripts, then of course the app can break. So it's always good advice to put it just in another folder and then let it run. So developing Shiny apps step by step. Really start really by scratch by setting up a complete blank page and then filling it with content after a while. So the virtual materials, if Dennis hasn't forked it yet, are also available, of course, on my. You have? Perfect. Thanks, Dennis, for forking. So you have the virtual materials here, all the scripts I've provided, the slides. It's not too much of content, but just in case someone wants to recap in the end, I think it helps a bit. So the features covered in the next around about 75 minutes is just building from scratch, building the plain UI, getting output objects, control widgets, implementing the server logic. So the first 3 steps are the UI. Then we have the connection to the server, to the backend, by implementing the server logic, the input-output reaction, rendering objects, and reactivity. Never mind that the words appear a bit strange right now. I'm going to explain them when we're at the stage. And in the end, a short outview to deployment. ShinyApps.io is basically just one click in RStudio. Deploy your own VM using Shiny Server cannot be done in this session here, but I will try to explain it conceptually what can be done there, because it's rather complicated and you need lots of fun with Unix code, and I don't know, I don't want to have this fun today. So, building Shiny app from scratch. If you already downloaded the repo, then you can just run script/install packages.r, just using the pacman package. All the required packages will be installed and loaded. And then you can just use run example in brackets, in parentheses 01_hello. And then the first Shiny app should run on your laptop. For those who have tried out, does this work? Hopefully.
While everybody's setting up on their machines, I might want to add that, as you know, we're live streaming today, which means we're also recording on the live stream. So if for any reasons you don't want your voices heard during any part of the live stream, please make sure to submit your questions in the chat so we can just read them.
Okay. I'll just show you this, how this should work. So we have just check whether all packages are loaded. Yes. So in the end, just running the script install packages and then typing in run example 01_hello, just should pop up this Shiny app for you, just to make sure that Shiny has been loaded correctly and your RStudio version is up to date. Because if you have really old RStudio version, might be that this automated launching of the app might not work. If you see something like this, or exactly this, then you're good to go. Okay. I don't see anyone complaining, so I'll just move on. So let's see where. So also you can check for other examples, just type in run example NA, and then you see, I think, 9 different apps, just examples of Shiny apps where you can get inspiration for your own app when you want to use different things. So building the Shiny app from scratch. It's basically 3 lines of code building the app. You need, as I mentioned before, the UI script and the server script, UI.r, server.r. In the UI.r, you just need to enter library Shiny, that within the app, the Shiny package will be loaded, because you have it, until now you only have it loaded on your RStudio session itself, but you also need to load the packages required for the app to function within the UI or the server. So somewhere you need to load the packages required for the Shiny app to run, and then just assign the fluid page, which is basically the overall page of the Shiny app, to the UI object. And in the server script, you just need to assign the function with input and output, curly brackets in the end, of course, to the server object. And then you should be good to go to run the app. I can show you what I've prepared here. So we have Shiny and Fluid Page over here. Hopefully it can be read by you quite. But all the code which appears here is also in the slides, so should be readable. And the server is just this. What you can see here in the server, on the top right corner of the source pane, is Run App. And you can just press it, and then you see a blank page. So we have now set up our first own Shiny app, of course without any content, but this is basically it. And our web development skills are quite zero-ish. But we are able to run this app locally at least. And basically this is the first step. And now, of course, we have to fill this with content. We need a nice user interface, we need server logic, and this is what we do now. So let's close this. So, building the plain UI. Basically, as I mentioned before, plain UI just make sure how the app should look like. So, building the UI, we make sure that we have all the text we need on our homepage. We have all the objects which will be filled in our Shiny app, and everything what just appears to the user is written in the UI. It's quite simple. Everything in the UI fits within the Fluid Page object. So you just put everything you need within the Fluid Page object, and new objects are just passed comma separated. And just the logic follows like this. First object appears on top, and then step by step filling it, just getting the objects iteratively down to the next one. You also can add simple text by just entering strings to the Fluid Page, and format this text by just using HTML wrappers. So again, you do not need proper HTML. There have been guys just wrapping the HTML functions into R functions, and then you can just use the more or less well-known objects H1, H2, strong, EM, BR to format your text, to enter some line breaks, make the text bold, what you just need to make it a bit more nicer. Also, we can use and add an official header using the title panel. And then we have an official title for our app, and it looks even better. So in our example, we only have built a plain white page right now. In order to make it nicer, we need an overall layout and fill this with some content. So the overall layout can be done by the sidebar layout object. This is just one of the layout formats. You can have different layout formats in Shiny. Also, you can build a dashboard where you can toggle around between different tabs. We'll stick to the easiest way to having a sidebar layout. So on the left-hand side, we have the input and the control widgets, and on the right-hand side, we have the output. Just plain and easy, the same appearance than this example app we've seen a few minutes ago. And as you can see here in the Fluid Page, we have the title panel, then we have the sidebar layout where we have the sidebar panel where your input goes, and the main panel where the results and the objects go. Just easy as in this. I would ask you to just set this up for your app, and then just check what the differences are between using H1 as a title and using the title panel as an actual title. So which differences can you see there? So did someone see what the difference is between the title panel and the H1 object? Yes.
Well, title uses H2 by default, which in HTML will be a smaller heading. H1.
And we also have a funny other. This is of course correct. If you open in the browser, and you can see using title panel, we have a name of our app as well. But just using the H1, other title does not appear in the header here. And you most often don't want to have your plain IP address and all of this just shown over there, as it is if you do not provide an actual title of your homepage. But just using the title panel, you have the title on top here, just again, some contribution to the user experience. We just want to have this Shiny app be really nice, that people want to use it, really can play around with it, and that you are able to communicate your results as a researcher better and in a really nice and readable way for a broader audience. So these are just these nitty-gritty details, but just make the app in the end look nicer. So, okay. Then most importantly, of course, for Shiny apps are input and control widgets. It's like we want the users to set different scenarios, test different model specifications, just change the appearance of plots, of tables, of outputs. For this, we need control widgets. So then users can specify certain inputs, enter text by themselves, select specific dates to just show a certain range of the year, something like this. Everything basically is possible. All input functions have, in essence, two arguments. We have the input ID and we have the label. The input ID is the name Shiny uses to refer to this input when retrieving values from the backend. So what does this mean? It means that we need an ID which is equivalent both in the front end and the back end. Because we always have user in the front end pressing a button, the information goes to the back end. The back end needs to know where this information has been put, and then we need to redirect again to the front end to see the result in the end. So we need an input ID both in the UI and in the server referring to the same type of object, basically. This input ID has to be unique. Makes, of course, sense. We are all social scientists, we know IDs have to be unique. Problem is, if you mess up, if you just have two IDs with the same name, Shiny won't give you an error message, but will behave really weird. So you don't really understand what's going on, but it's just not behaving as it should because it just does not know which ID refers to which object and how front-end and back-end should communicate to each other. So just always be aware that your input IDs are correctly named. Label in the end, pretty easy. It's just the text displaying the label of the control widget. Some examples shown here. And as you can see, we could input basically anything. We have an action button to just let some interactive stuff run, just like action, and then some slideshow appears or something else. Checkbox input from a single choice, multiple choice. We have date inputs, range, numeric. You can either also enter passwords if you want to have a separate and secure area within your app. You can have sliders, radio buttons, even color input to change the color of your of the plot if you want. So basically everything what is possible in changing the appearance of plots and R objects by you as an individual user of your own can be done by the users of your app as well. So there are basically, as I would imagine, there is no input I as a user in a normal R session would be able to do so, which is not shown in this chart. And also this might even gets updated if we find another input which is not shown here. The control widgets go to the sidebar panel. This is important because otherwise you have the control widgets really in the main panel. In this bigger part of the panel, it looks a bit weird. So the control widget should always go in the sidebar panel. And then this is the kind of web development. This is you as people like you have a beautiful app. Just depending on the design of your app, depending on what your app should do, just choose the control widgets. You by yourself know best which control widgets are most appropriate for the changes in the app which should be done, and this is up to you. I'll show you 3 examples of the most common widgets. It's the radio buttons, just pressing buttons, selecting the input, or using the slider. I think these are 3 most common and particularly useful for us. The radio buttons is basically quite easy. We have this input ID, like as I just call it, the buttons. And then, because we're using the Titanic data set later on, it's the question, did the passenger survive? And we have to specify the choices we have. Did not survive as 0, did survive as 1. Here you can see the actual input is 0 and 1, but we can provide labels for the checkboxes already here. So we can manipulate the appearance of this radio button already within the simple function, and pre-selected is 0, just to make sure that we have the radio button already pressed. And this is basically the idea of all of these widgets. So we have this ID, we have text, and then some further specifications how these widgets should look like. Select input is the same. We have the selector, this is our input ID. We have a label, select the class of the passenger, and then the choices 1, 2, 3. For selecting input, of course, we have no pre-selection because this would be rather strange. It's just like a top-down list where the user can specify the choice he or she wants. Slider input is slightly, minimally more complicated. We do not have one specification here, but also, of course, min, max, and pre-specified range of values pre-selected. And we also can specify whether it should be dollar or euros, or again, just providing another layer of user interface, nice user interface. All of these control widgets, as I said, go in the sidebar panel and then should work by themselves. However, until now, we have only specified the control widgets per se, but no output will be provided. The control widgets just show the way how you can manipulate stuff, but we also need, of course, an object where the results coming from the backend will be shown in the UI. These outputs might be anything, basically. Also plots, tables, text, images, maps, videos, whatsoever. In the UI, we just build the placeholder. It's just like we need a position where to put this output, and in the actual music plays, of course, in the server. Because we have the control widget, the user specifies what he or she wants, gets to the back end. Here the magic happens, and back in the front end, we have an output of a specific object depending on the choices the user made beforehand. Of course, we have in the output function, we have this output ID, which need to match the input ID. So we have this plot output object for plots, just getting them in the main panel and having here an output ID where the object created on the server side will be shown on the UI. So we have this input IDs for the control widget. This is what the user provides. And the output ID is what the server produces from the input created. So this is what we have to bear in mind. So we have input IDs and we have output IDs. Input IDs is what the user provides, and the output ID is what has been done server side, the logic of the app, and is then redirected to the UI again. Was the question back in?
Yeah, just because I'm stuck on this and I didn't get it. If I now want to load basically a plot or be able to load a plot or a table or whatever onto my app, do I generate the plot, save the plot in the folder, and then the server will pick the plot, or do I actually run the analysis in the server RScript?
You can do both, actually. The standard way is, of course, producing the app in and producing the plot in the app.
Okay.
and then do all the calculations there, and then the plot will be shown in the UI. For our appendix, which I showed you in the beginning, this was not possible because running all the analyses beforehand would take about 2 to 3 hours, and then showing the app after 2 to 3 hours, the user would never wait this long. So we decided to run the calculations beforehand, saving the objects of the plots and then just showing the plots. But always depends on the computational time, basically. If it really takes a few minutes for the calculation to be run, then I would outsource it, and then using some external database like MongoDB, SQL or something to get the data in, or just store it locally somewhere if the data isn't too big, and then you can just load the objects in and then show the plot. This always is up to you, because this is the nice thing. Everything we can do in R, we can do in Shiny as well. And in R, we always can make the decision how we want to present our stuff, how and where we want to do the calculations beforehand, or run it every time we rerun the script. The same can be done in Shiny. Great, thanks for the question. Other output forms are basically table output, text output, what you will. You can just check the Shiny homepage. There you can see all the outputs. And as I said, they always should be in the main panel, which makes, I think, intuitively sense. So let's go to the first big exercise. When having run this install packages script, you should be able to glimpse the Titanic train data set. If you aren't aware of it, just check it out, make yourself familiar with the data set, and then we aim to do a classic data presentation app. In my app, which I did as an example, I just plotted the age distribution in the histogram and then specified some control widgets. You can do whatever you want, actually. I think you're all able to do this in R, to just set up some simple plot, set up some control widgets, and see whether you can fit it all within your app to have nice control widgets in the sidebar panel and a placeholder for the output in the main panel. So I'll just go around, see whether someone has issues, and otherwise enjoy. I think up to 10 minutes at most should be fine. Yeah. And to those being online, if you need some assistance or help, just write it in the chat, and we'll try to do this yeah, somehow.
Do you want to use your microphone for the time being? Yeah. Just.
In exercise 1, we just set up the user interface, adding radio buttons, selector, slider input, and in the main panel, the placeholder. This is in this take, this comes later. And on the server side, we still don't have anything. So simply, we just have an app where users can play around, but in the end, nothing will be shown because we haven't told Shiny yet what to do with the input on the back end. So we can just toggle around here, specify different classes, pick a different range of fare, but in the end, we do not see any output here because we only have the placeholder right now. In order to change this, we need to implement the server logic. And the server logic means switching from the front end to the back end now. So we always had the server logic from the beginning that we have an input and an output argument. in our server functions. This is what we have set up really in the beginning by having our 3 lines of code app. We had already the input and the output argument. These are necessary for the server function. Input contains the values of the input given by the users, so what the user provides for the app. Outputs are the plots and table created based on the values from the input. So this is always this connection, input, output, input, which moves all the way. Output objects can be created without any input specification, but then of course the user cannot change it. So you can just build a static plot, but then you cannot connect it to the control widgets, to the input provided by the users. The standard procedure for choosing any object in the backend is we need to store the output object into the output list. I will show you in a second how this looks like. Build the object using a render function. For every object type, there is a unique type of rendering to make it more efficient. And then a third point, which is not mandatory, access input values using the input list. So there is the connection between input and output. The third step allows users to change the appearance of the plot, change the app to a certain degree. So when only having the first 2 conditions met, we need the IDs and the output and the render function. In my placeholder, I called the plot grade plot. Of course, on the server, I have to name it the same way. And I added to the output list by just entering output $grade plot, then will be automatically added to an empty output list, which will be filled by all the objects I produce in the server. We just create a new object by just assigning the respective ID to the object and enter it to the list of the output. Basically, this is the logic to build the app, per se, to let the user in the end see the results of his changes. And then we need the rendering function here, render plot, and can just plot normal distributed scatter plot. Oh, I don't know. Yeah, we have to assign it to this ID, and the render function is render plot. Problem is, of course, this is a static plot. So when the user changes anything, this plot will not change because we have no connection to the input. We have no input ID within the render function. So we have no possibility as a user to change stuff. Connecting the input and the control widget to the output requires us to take objects from the input list and assign them to the plots created in the output. So here we can see we need, again, this grade plot, the render plot function, and now we've added an input object named after our specific control widget. So our slider input has the input ID slider, except this name has to show up here, and then the respective value you want to pull out of this input. Here we have this connection between input, output, and back to the input. The list, the logic behind the input list is the same for the output list. So they are specified in the UI beforehand. In the UI, all of the IDs are pre-specified and need to find a match in the server, so in the backend. And then you specify it. So, and then when rendering these plots, we can add as many functions and code and whatsoever as we want. Since we have the render plot both with the standard brackets and the curly brackets, we are allowed to have several lines of code in here. So we can have data manipulation, plot creation, plot revision, all within this function. Here, just the ggplot instead of the normal plot, and added the histogram to this, so just plotting the age distribution of the Titanic data set. And this still is not interactive because we have no connection to the input ID, but we can easily filter the data set by our control widgets. So this is basically one simple idea of adding an interactive component. Just filter the data set by specific scenarios. And to do so, we'll still in the render plot function, but add another object named filtered data, which will be filtered according to the input provided by the user. So the user decides where to put the first button of the slider, where to put the second button. This is the range for the fare included in the filtered data. He or she selects a specific class with for the ticket of the passenger and whether they have survived or not. And based on this filtering, we plot the filtered data. So we have the interactivity pulled out of the plot itself, and the plot will be changing depending on the input provided by the user. I think this is the most simple way of providing interactivity here, but you can, I think, come up with hundreds of different ways how to make this interactive. Just always have to consider that you need this input $input ID specification to really assign to the correct control widgets, and to have this output ID on top correctly assigned to the placeholder in the UI, and then everything should work out well. This is basically more or less it of building the Shiny app. I'll now come to some specifications to make it a bit more efficient, because we want the users to be happy with our app and not having to wait half a minute for each and any histogram to be reloaded and having eating them all of their memory, because we have to be responsible for the user as well, not forcing them to load a 3 GB app beforehand and crushing their PC by just running our small Shiny app. So we need to consider memory problems and repetition as well. And one of the easiest way to control for memory problems and reactivity is the reactive object. And the reactive object makes it easy to separate the filtering, so the changes made by the users from the actual plotting. So instead of running the whole code all the time when rerunning and re-specifying anything in the plot, we can separate the interactive component from the static component, making it much more memory friendly, because this will be free. The memory will not be stored permanently when the app is running, but just be overwritten, and only the plots will be re-rendered all the time, not everything. On this mistake, I've changed the slides. This is the next one. This ly needs to be erased. I'll update it afterwards. And here we have then a reactive object called filtered, does exactly the same than here. But the major difference is this object is not a static object, because it is per se interactive. It is reactive, reacts on input provided by the users. So it is as such a type of function, so it needs to be added as a function here, not as a static object. So adding brackets in the end. Also, very important, you cannot access this object outside of the Shiny app. It is a reactive object, so it requires necessarily input by a user. And you cannot provide this outside of the Shiny app, because it has this reaction to the Shiny logic. And in the end, it is not too complicated to add this reactive component, but helps you maintaining and running a smooth and simple and really easy to run app. Lastly, I don't know if you are aware of the Plotly package. Plotly package allows users to toggle on the plot themselves, zooming in for specific values, getting some highlights on the values, some further information on specific dots in a scatter plot. This is perfect use case for Shiny, because this is what we want. We want the users to have full flexibility, really to zoom into the data, zoom into the results, and do whatever they want, what we allow them, of course, to do, but within this this arrangement, do whatever they want. And Plotly allows them to really zoom into each and every dot and to check specific values. It is extremely easy to make a ggplot to a Plotly plot, so this interactive plot. Just have the same code than before, assign the ggplot to a new object, I call it plothist, and then let the ggplotly function run on the plothist object. You cannot simply run the ggplotly in with the ggplot options, because it is just a refactoring of the ggplot object and not the ggplot function per se. So we need this second step, but this is basically it. And when you will run by yourself in a second, you see that it changes the picture massively. So this is what we do now. So you can either copy and paste the server logic I've written for the H distribution, or come up with some by yourself. See whether you can create a reactive object to add flexibility to your app, perhaps find some solution to reset the filter options, whatever you want, or a second output. Again, I would suggest having 10 minutes to let you play around. I'll move around, see whether I can help. And after this exercise, we'll move on to the deployment part, having your app run globally in the World Wide Web. So, and this is, I think, on Java stuff, I don't know. So it is inherently different to a ggplot. So both in the UI, we need to replace plot output with plotly output, and in the server, replace render plot by render plotly. Otherwise, it won't be shown in the UI. Some time to play around. I'll just show you what I've added to our server in this last exercise of the Shiny app development. And in the end, it works more or less. So we still have, of course, the reactive. I did not change anything there, but I've added a few new widgets. So what we can see here is you can add a kind of filter activator over here, whether to activate the filtering at all or not. So right now we have the full data set plotted here. By activating all filters, all these filters here will immediately be applied, and then we can toggle around, see class and age distribution, those not having survived. What I've also added is a text output showing how many passengers have survived using your filter. Of course, this filter changes the picture massively, because if I specify only those have died should be put in the plot, then no one will have survived. But here we can see 78 passengers have survived, being the second class and having a fare between $10 and $215. And then by deactivating the filters again, we see in total 342 passengers have survived. How I've done this is pretty simple. So at first, I've added this checkbox over here to activate all filters, just as a default setting on false. Then I can change it to true by marking the checkbox. And in the end also, which I neglect for a second, is just you can also, of course, enter different variables to be plotted simply. Just adding the respective names of the variables in the data set here, and then you can plot different variables. In the server, you can just add specific if-else conditions. This is how we tell Shiny that one or another situation should be displayed. So we have, if the checkbox is true, then please apply the filtered object, the reactive object. If the checkbox is false, just take the normal unfiltered Titanic training data set. And then in order to add this text, again, if else condition, if the checkbox is true, use the filtered data set. Please paste this text. Else, use the Titanic data set and paste a different type of text. This makes not only the object within R or the number appearing here interactive, but also the whole text. Because just in certain situations, in certain filters being applied, just different text will be produced in the UI in the end. But it's all in the repo. If you want, take your time to check it out. If you have any questions, just drop me a line and we can discuss the matters. The last part of this workshop is deployment. And deployment just means that we take our apps which only run locally. So you are not able to show anyone else your app despite taking your laptop with you and giving him the laptop, see my fancy schmancy Shiny app. So in order to present your app to your friends, family, and whoever needs to see this app, you have to deploy it to the World Wide Web. This means also that the app has to be secured. It has to be protected by a firewall. You need a stable URL that you can access it at any time. Otherwise, by not having it being protected by a firewall, your laptop will be killed within minutes, perhaps. And without a stable URL, you cannot find it in the World Wide Web, of course. Since we aren't server maintenance, DevOps, or whatsoever, we can use the homepage shinyapps.io. There is a free plan where you can deploy your Shiny apps, small Shiny apps. If they exceed a certain size, here again the memory issue comes back. Then the plan becomes costly, and if you have too many visitors on your Shiny app, then you will have to switch on a costly plan as well. These costly plans are extremely expensive. So try to keep your app small and don't spread it in Facebook groups that thousands of people try to access your app, because then it will be locked until you go to the costly plan. But luckily is the Shiny Apps team will take care of any matter of homepage maintenance whatsoever. So both firewall, stable URL will all be provided by Shiny Apps. So this is a service. If you have really a big Shiny app, you want to host it for the university, for a big research group, then it might make sense to have a costly plan, because then everything is taken care of. But be aware it costs, I don't know, can be up to a few $100 a month. So it can become really expensive, these big plans, these company plans. Deployment using Shiny Apps is extremely simple. Just create a free account on shinyapps.io. I would suggest using your university email address. They just check sometimes whether they are spam emails or not. With the university email address, you're on the safe side, because then you can verify easily. Then go back to RStudio and then press the deploy button on the top right corner of the source pane and wait. Takes about 3 to 4 minutes, and then it's deployed on Shiny Apps. I'll just show you how the deployment works. In the meanwhile, if you want, you can create an account on shinyapps.io if you haven't done so before. And then you just need to press this tiny little button, this blue one here, and publish, and then just wait. Easy as this, but I won't do this right now. Wait for you to have this Shiny Apps, and if any one of you wants to, can immediately deploy it and then share the URL with anyone you want, because you're all web developers now.
The URL takes the name of the
Folder, project. Mostly project, but you can re-specify it when publishing it. You can give it a new name. Of course, it has to be free, but the base URL will be shinyapps.io, of course. But the name of the app yourself, you can freely specify. You can just check it here. So then you can create new, and then you can specify how you want to have it called, and then deploy it under name if you want. So in order, I think this can be done by each and everyone by themselves. This is really easy and makes it extremely convenient for us not being DevOps to deploy apps. If one is really eager to do this by themselves, either because they don't want to use this costly plan but run a massively big Shiny app, or you want really full control over your app, so access control, who is allowed to access the app, can block certain IP addresses whatsoever, or you really are eager to learn Unix, you can deploy Shiny apps on your own server using Shiny Server. So this goes way beyond what this workshop is about. So I will just provide you a conceptual idea of how it can be done using the BW Cloud, freely accessible of all members of the University of Mannheim. So we can have our own server hosted by, I think, the KIT, that allows us to have virtual machines which can act as a server, which are stable, which will not, in normal cases, break down. And you can just run your Shiny server there by yourself, but be aware, it is Linux what you're working on, and Linux is not known as the most user-friendly OS ever, or OSs. So basically, to reiterate, Shiny Server is a free alternative. You can avoid the costly plan, and by being a member of the University of Mannheim, you can also avoid different hoster for your server, like DigitalOcean, AWS, which of course also costs. If you want to have a server by them, will cost you the same. Will also cost you $5 to $10 a month. By using the BW Cloud, also quite neat maintenance and service here. It is completely for free to run in really big apps.
Konstantin, question on that. So if we were to host something on the BW Cloud,
yes,
we first use Shiny Server, and then whatever Shiny Server produces will be hosted on the cloud, or how does it work?
It's basically, we have the server, and on the server we install Shiny Server and put our app on the server.
Okay.
Then the server itself has a stable URL, has an IP address, and an open port where all the output produced by the server can be shown to the World Wide Web. So basically on the server, you can put the app and then access it. If you open the ports, access the content of the server, of the Shiny server, on any browser you want.
At what point does the protection come in? Is that
This is
Shiny Server?
it is offered by the BW Cloud, but you have to check whether the firewall is specified in the way you want it to be specified. So you really have to take care that someone really well educated in server maintenance and data security just looks over your own server before opening up the ports and then letting all of the bad guys in. Because the problem is, if they are on your server, then they are potentially on all the servers in the BW Cloud.
I see. And who the person be would check?
You can either just ask the service team from the BW Cloud or go to our SOVI support. They also know a lot about the BW Cloud. Most of the time, the ports are rather restrictive, so you really need to massively manipulate the server to screw up, but just in case, let someone else look over it to be sure that nothing is open what should not be open. In order to get to your own server, it's pretty easy. The first steps are pretty easy. So at first, you just need to register for the BW Cloud. As I said, any member of the University of Mannheim, I think of any university in Baden-Württemberg, is allowed to have an account here and free server capacity. Then log into the BW Cloud dashboard. I'll show you in a second how this looks. From step 3 on, it's getting a bit nasty because we now need a secure connection from the server to your computer. You have to be able somehow to communicate to the server, and this is done via an SSH key pair, where you have a private and a public key, which are unique, and especially the private key has to be hidden from the public, making sure that the server knows you are the one, you are the admin being responsible for the server, having the allowance to go into the server. And by using PuTTY and FileZilla, you are able to run commands on your server using your own laptop. This all is extremely techy, so I won't show the details to you here, but this is basically the way to go. So getting the server from the BW Cloud, connecting the server via an SSH key pair, and then accessing the server using PuTTY. In Mac, you can just use console and shell, and FileZilla to move files back and forth to the server. Because the server itself will be only DOS Outlook, so you cannot do much there. There is no really user interface for the server. It's just like a black shell screen showing up. And then you build up your virtual machine, setting how big it should be. So setting the volume, setting the RAM, everything you can set by yourself, and then run the virtual machine. Just a short glimpse here. The dashboard looks like this. Just through it. So we have basically a dashboard showing how many servers are run at the moment. So I have one server using all the CPUs, all the RAM, so just with one big server. But the volume storage is rather small, just 4 gigabytes. Also, the network is just using one security group, of course, because I have one server. Of course, it can be distributed even further, but all of this is not of a big interest for social scientists, I believe. So just should leave this as possible to the guys really knowing more about this. But Chinese server by itself, just if you are able to set Chinese server up at once, which will take you, I believe, 1 to 2 days, if you're lucky, then you can maintain your own Chinese server, and then getting new apps on Chinese server is extremely easy. But to get to this step, Linux is a pain in the ass. Because it's just like not having some exe files which you can double click. Now you have all the ingredients, and yeah, go compile them by yourself. So starting from just installing R on Linux is a bit nasty, because of course you can use the standard command to install programs. Linux sudo apt-get, so you're as an admin trying to get a new app. Installing rbase, if you're lucky, the correct version is stored in the apt-get. Most probably you're not. So you will have to go to the R homepage, download the respective files. You need to install R on Linux, get them on the server using FileZilla or some other tool, and then reinstall the latest version of R, because I think the last version here is 3.4 something, which will not work with RStudio, as some of you already experienced with 3.5 or 3.6. When having done this, need to install several dependencies to be able to compile and install packages by themselves. Then Third point is the easiest one because then you have R running, and then you can just enter R and install all the packages there. This is the only easy part here. Installing Shiny Server is again getting the latest version, installing it, setting the correct name here. If you're lucky, this has worked. Then you need to open the port 3838. This is the port Shiny Server runs on. Again, take some help by someone really knowing stuff about server maintenance and others, because this can really screw up a lot. But if everything worked out fine, you're able to access the Shiny Server. So this is Shiny Server running on my virtual machine, on my server, using the port 3838. And here you can see Shiny Server is alive, it works. And by just adding the UI and server files to the respective folder of Shiny Server allows us to just get new apps on our own Shiny Server and having them maintained and updated by ourselves. As I said right here in the last point, it's like just FileZilla, access your server, upload your upload files, app files to server Shiny Server, and then it should work. Like our appendix app is just built on this Shiny Server URL. You can mask this URL with a more beautiful URL, and then you have a Shiny app run by your own Shiny Server, and you're able to maintain it in any way you want. Most probably, this won't work first step. Basically, not even the second, perhaps the third one. For those of you eager to do so, I am glad to help as possible. Not in any step I will be able to help, but with the few fundamentals and with the setting up the BB Cloud and the server, I can help you if you want. Here I have linked a tutorial where you can get the last steps, and there's a lot of troubleshooting also in this tutorial for basically any known incident which is known to somehow appear. There is somewhat of a solution here, but in the end it is lots of trial and error, especially for us not being DevOps. So this was it. Thank you for listening to the workshop. Thanks for the audience in the World Wide Web, and hope you enjoyed. Hope you're glad to be a web developer now, and looking forward to see some new cool Shiny apps. Thank you.